Imagine a single sewing needle fired straight at the sun at 1,000,000 times the speed of light. No warning, no time to react, just a sliver of metal ripping through space, so fast it outruns every ray of sunlight ever made. Would it punch a tunnel through the sun, trigger a star-killing blast, or would the greatest engine in our solar system barely notice at all? But before we imagine what happens to the sun, we must ask, is this even possible? Einstein's theory of relativity tells us nothing with mass can move faster than light. Why? Because the closer an object gets to light speed, the heavier it becomes. Its energy demand grows without limit, approaching infinity. At 1,000,000 times the speed of light, our tiny needle would require an infinite amount of energy. So, in reality, this needle cannot exist. But what if we break the rules just for a moment and try to calculate the unimaginable? Let's imagine, for the sake of thought, our needle weighs only 1 gram, about the weight of a paper clip. If it traveled close to the speed of light, its energy would follow Einstein's famous equation, E equals mc squared. 1 gram times the speed of light squared is about 90 trillion joules. That's the same as dropping 20,000 tons of TNT from just a single gram moving at light speed. Now imagine it not just at light speed, but 1,000,000 times faster. The number becomes so large, it dwarfs every nuclear weapon ever built. The impact would unleash an energy capable of shaking the very core of the sun itself. So what happens if such an impossible needle slams into the sun? At first, almost nothing changes. The sun is unimaginably massive, 330,000 times the weight of Earth. A single gram, no matter how fast, is nothing compared to the sun's mass. But the energy of the impact is another story. It would punch into the solar plasma like a bullet through water, sending shockwaves racing outward. The local region would flare with blinding light, hotter than the sun's core itself. Massive solar storms could erupt, hurling plasma into space. Yet even then, the sun as a whole would survive. For a star born to burn for billions of years, even the fury of a super-weaponized needle is just a ripple in its endless fire. But the solar system around the sun would not escape so easily. A solar flare of such scale could blast through space as a coronal mass ejection. If Earth stood in its path, our magnetic field would be overwhelmed, satellites destroyed, power grids collapsed, the night sky glowing with auroras brighter than day. Mars, Jupiter, even distant Neptune would feel the wave of radiation. Though their orbits would remain, the system itself would tremble, as if a stone had been thrown into the calm waters of space. But what if the needle did not strike the sun, but Earth itself? A single gram at light speed holds the energy of 20,000 tons of TNT. At 1,000,000 times faster, the energy release would defy imagination. The impact would vaporize everything in its path, drilling through the planet in an instant. Mountains, oceans, and even the Earth's core would tear open like paper. The explosion would unleash more energy than all nuclear weapons on Earth combined, not just once, but many times over. In less than a heartbeat, Earth would be shattered apart, its fragments hurled into space, glowing like a new asteroid belt around the sun. For our world, the story would end not with fire, but with a single, impossible needle. So could this ever be done? The answer is no. Nothing with mass can outrun light. Not a rocket, not a needle, not even our boldest dreams of technology. But by asking the question, we unlock a truth, that matter and motion carries power beyond comprehension. Even the smallest object, if accelerated enough, can rival the fury of stars. The sun would survive such a strike, Earth would not. And it leaves us with a haunting question. If a single gram can hide the energy of worlds, what else is hidden in the fabric of the universe, waiting to be unleashed?